Hello and welcome to another lecture. In this lecture, we're going to talk about the braking distance of a vehicle. What it means when you apply the brake at a certain speed, how long it will take for the vehicle to come to a stop. Remember, we're just doing a braking distance. We're not talking about the reaction time. There will be stopping distance. That's the difference. So we're just doing a braking distance. And then in here, we're going to do an example to try to calculate the speed of a vehicle based on a skid mark or braking distance. Anyway, so when we look at this, AASHTO have come up with this incredible formula is that braking distance is equal speed squared divided by 30 times A over G is basically a friction of the tire plus or minus of G. And what I have here, let me do some reading here. The deceleration rate is 11.2 feet per second. It's used because it's a very comfortable deceleration rate. However, in a case of emergency, when people they do a deceleration rate is greater than about 14.8 feet, 14.8 feet per second square. Anyway, so let's look at the problem here. Felicity is trying to find out her car brake ability of her new car. So what she did, she drove the vehicle on a downhill and applied the brake. And then she just drove the same vehicle or the same speed on a downhill at 3% grade and found out when she's on a downhill, she needs about 18 and a half feet more distance to for the same speed. So now find out what is the speed of the vehicle she was traveling. Also, what if she was going uphill at 5%? What would be this braking distance at that same speed that she was going? All right, let's get to work. Okay, so let's review the problem. When she started going at a certain speed at 5% downhill and stopped pushing on a brake at this location and stopped making her brake right here, and it takes her a distance of x to stop. So she does the same exact thing on a 3% hill, which is this yellow line right here. And then when she push on a brake at a certain same speed, and it takes her about 18 and a half feet less than when she was doing a 5%. We like to know what is the speed, and then we like to know what if she drive up at 5%, what will be the stopping distance, braking distance. Remember, this is a braking distance. It doesn't include the reaction time. So here's the equation. Right now we have 30 times u squared divided by times 30, u squared divided by 30 times A over G. A over G is a friction minus G is the grade of the road. A over G is basically given by AASHTO is 11.2 divided by 32.2, and that comes out to 0.347. So what we're going to do right now here, we're going to say if distance x, which is the green, minus this distance up here, which is x minus 18.5, the difference between those two areas are about 18.5. And now I'm just going to plug in the formula for this and for this right here. So basically x is equal to u squared divided by 30 times 0.37. This comes out to be u squared divided by 8.91, and this one is equal to u squared divided by 9.51. So if I go ahead and put in this to an equation, we're going to have 0.111 u squared minus 0.105 u squared, and that's equal 18.5. And from here, u basically comes out to be 55.5 mile per hour. Now we have calculated that. All I did here, brought this equation down right here and I put it in here. X is right here. This became x, and this became x minus 18 from above. And now we want to calculate the going uphill. What if you go uphill right here at 5% going up here at the speed of 55 mile per hour, and if you slam on a brake right here, how long distance is it going to take you? So the dB, it's going to be u squared, which is basically 55.5 squared divided by 30 times 0.347 plus 5%, and that will give us 258 feet. That's it. You have a great day.